what they want. Alright, Bass, just got a close up. That was probably disgusting. Anyway, I'm here. Quiz review. We're going to get you ready for this whole quiz. I'm going to give you literally all the parts. Alright, so you got two skills that you're tested on. Skill one is the properties of exponents and modeling. What I actually want you to do is write these down right now, pause it, and try to evaluate them / simplify them as much as you can. So go ahead and do that. Cool, you did that. Alright, so this is one of our exponential properties. What is this? This is the product rule. This is the product rule for exponents right here. And this says if the base is the same, they're being multiplied, you're going to add these exponents. So this is 8 to the 3 plus 4, which is ultimately 8 to the 7th power. Okay? I'm not going to go through all the details of it, but I'm just reminding you. That's that product rule. Same base, they're being multiplied, you can add the exponents. Alright? Now we're going to have another rule right here. Actually, I'm going to take this negative exponent out of this, right? This we can simplify to 1/4. But then we could use a quotient rule. Okay? So this has the same base, they're being divided. You subtract, so it's 2 minus 2, and this is the y, 4 minus 3, which becomes 1/4 x to the 0 power, y to the 1st power. Okay? So we did that one. That is our, what's this? Quotient rule. Quotient. That's the quotient rule. Because you're dividing. When you see the exponents of the same base being divided, you ultimately subtract the exponents. Alright? Here we have our power rule. Right? If I have something that already has a power, and I take it to another power, I actually multiply it. So this means 7 to the 1 times 3. It's kind of like distributing. And this is x to the 2 times 3, which ultimately becomes 7 to the 3rd, x to the 6th. That's your power rule. Okay, now we're going to talk a little bit about these fractional exponents. Okay, so again, you know, we have this right here. If I want to do this, this is 4x. You take everything that's inside here, that's the base, and I'm breaking it into one group of 3. So this is 4x to the 1/3 power. Okay? That'd be 4x to the 1/3 power. But it's important that you put this parentheses around it. So I'm saying that all of this is going to the 1/3 power, not just x. Right? So that's our fractional exponent rule. And finally, there's a negative exponent rule. I'll write it right here. Let's say if I have x to the -3, y squared, z to the 4th, and I want to write this without negative exponents. I take this, to get rid of a negative exponent, I do the reciprocal, so this becomes 1 over x to the 3rd, y squared still stays in the numerator, z to the 4th still stays in the numerator, right? So I'm just going to separate that. And this is your negative exponent rule. So you got those 4 rules that we just did right here. You got to know how to use them, how to manipulate them, all right? That's the end of this first part. I'm going to pause it here. I'm going to write up the second part. All right, now we're going to talk about some modeling using exponential rules. First, write this down. Yes, Henry and some others, write this down. All right? So I bought an antique pen for 16 bucks. 4 years later, it's worth 32 bucks. It is increasing exponentially. Write an equation for this, and how much will it be worth after 10, is that years? Yeah, after 10 years, okay? I want you to go ahead and try to solve this first. So you can pause it right now, try to solve it. Cool, you should have just done that. Now I'm gonna go solve it. So I always start this by making a table, right? So I have this table, and I say I got this pen in year 0, it was 16 bucks. Here's year 1, here's year 2, here's year 3, and it's at 4 years later. So here's year 4, it's in 32 bucks. So it is doubling. It's going times 2 every 4 years, right? So I need my initial, my growth rate to be a 2, but it needs to be over 4 years, right? So I need to know what B is. So basically, B times B times B times B, right? If I multiply it here, 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 and here, 1, 2, 3, 4, that needs to equal 2. So B to the 4th power needs to equal my growth rate of 2 because it happens over 4 years. So I take a cubed root of that, and I have to take a fourth root, fourth root of this and a fourth root of this. These cancel out, so I'm left with B equals whatever the fourth root of 2 is, right? So now I need to know that, well, B is the fourth root of 2, or that is 2 to the 1/4 power. That's the key. It's 2 to the 1/4 power. So B equals 2 to the 1/4 power. Okay? So if I'm now creating my equation, my total value equals my initial value, which is 16, times my growth rate, which is 2 to the 1/4 power, times x. Right? Initial value, growth rate to the x power, or to the x exponent. Except I don't want it to look like this. So I also know that this is 16. If this is 2 to the 1/4 times x, I can actually multiply those together using the power rule. So I get 2 to the, and if I do 1/4 times x over 1, I get x over 4. 2 to the x over 4. And this shows me what I need to know. I started with 16, and it is doubling times 2 over every 4 years. So that's what I want to end up with. This is the format that you're going to need to use it for with this test, right? So then the next question asks, well, what's it going to be in 10 years? So in that case, I just plug a 10 in here. 16 times 2 to the 10 over 4. I'd figure out what 10 divided by 4 is. I'd get whatever that power is, and I'd solve it. I'm not going to solve that part. You guys can solve that part. I assume you want to make this video quick, but you should figure out this final answer for the cost after 10 years equals what? All right, I'll pause to the next section. All right, y'all, now skill 2 is talking all about using logs to solve equations, using the log properties and modeling. So we're going to start off with just some basic equations, all right? So we're going to solve this. Actually, I'd like you to pause and solve all of these on your own right now before I do it. Haha, cool, you did that because you're awesome. So you're saying, okay, I need to solve this thing. It's an equation. So the first thing I'm going to do is I want to isolate the base with the exponent. So I'm going to divide by 30, and I'm going to divide by 30. So I end up with 6 to the x equals whatever 100,000 divided by 30 is. What's that? 100,000 divided by 30 is 333.33. Okay? The third of it. It's basically divided by 3. Right? So now that I've got my base isolated, I need to now, what a log does is it allows me to find an exponent. So if I have a base 6 and I want to get rid of this, so I'm looking for the exponent, I take the log 6 of 6 because those cancel and they just leave me with x. But I must do the same thing on this other side. So I'm going to take also the log base 6 of 3333.33. Now here's the pretty part of it, right? Our calculator cannot do this because it can only do base 10. So we need to use that that change of base rule. You're gonna need to know this. So I'm gonna take the log base 10 in my calculator of this, of 3333.33, over the log base 10 of 6. And I'm gonna divide these out and see what I get. So let me do this on my calculator right here. You should be doing that as well. Let's go. So 3333.33 log base 10. No, they didn't make that clear. 3333.33. That's about 3.52 over, I'm going to do log base 10 of 6. So 6 log base 10, which is 0.78. And now I'm going to take 3.52 divided by 0.78. And I ultimately get x equaling 4.513. Right? So it's about 4.513 is my final answer. And maybe it's here, 4.513, because you might not be able to see it over there. Right? So I couldn't do this because I needed a change of base rule to help me be able to get that answer. This one here, this is nice and easy. I got base 10 to the x. It is being, it's already isolated. So to get rid of that, I want to take a log base 10 of 10, those cancel. And I need to do a log base 10 of 475. Luckily for me, my calculator can do that one already. I don't need to change the base because I'm already on base 10. So let me see, 475, come on, calculator switch. 475 log base 10, let me check that. 475 log base 10, and I get x equals 2.677, something around there. Okay? There's my answer. 10 to the 2.677 power would get me 475. Alright, so now I'm going down to this last one. What is the log base 2 of 128? So again, I have to think about, well, what does this actually mean? This means if I take a base of 2 to some power, it's going to equal 128. Well, 2 to the first is 2, to the second is 4, to the third is 8, to the fourth is 16, to the fifth is 32, to the sixth is 64, to the seventh is 128. X equals 7. 2 to the 7th power is 128. We getting there, y'all. 2 more left. Let's get it.